Everybody ready?
Yep.
Hold on tight, we're going to Mars. You will find it as the fourth planet out from the sun, just a little bit farther out from us. So you got Mercury, and then Venus, and then Earth, the big blue marble, and then Mars. Looks pretty small, doesn't it? Turns out that that's because it is. Mars is only about half the diameter of the Earth, only 1/3 of the gravity. So walking around on Mars would be a pretty floaty, bouncy kind of experience. Almost as floaty, bouncy as the moon, but that's a 6th gravity. Mars being a 3rd gravity is close. That's something that's not shown in the movies. When you see people walking around on Mars in the movies, they look like they're stomping around on Earth. Probably that's because that's where the filming studios are. I do have one clarification on this picture. Mars is not, in reality, not actually this close to Earth. So how far is Mars? Well, that's actually an important question, and it depends a lot on when you're asking. So I've got a diagram here that shows the sun as a little yellow dot in the middle here, and then Earth is a blue dot, and you can see Earth's orbit going around the sun. And then Mars is a red dot. You can see Mars's orbit going around the sun. And Earth, being significantly closer to the sun than Mars, feels a much stronger pull of gravity from the sun. So Earth has to go faster than Mars to stay in orbit. Earth's going 67,000 miles an hour. Mars is going slower, about 54,000 miles an hour on average. Mars is also farther out and has a larger orbit that it has to travel. So while Earth gets around the sun in about a year, Mars takes close to 2 years to complete an orbit. What that ends up meaning is that we pass Mars about every 2 years. So let's take a look at how that works. I have them lined up here. This isn't where we are now. This is where we were the previous time we passed Mars in July of 2018. So I'm going to get them started moving. And the first thing you can see is that Earth is moving a lot faster than Mars. I'm going to stop Earth when it gets back to the starting point, right about there. So Earth has gone all the way around once. So it's now about July of 2019. And Mars has made it only about halfway around. So it's at the far extreme other side of its orbit. It's about 6 times as far away as it was when we were passing it. And if you were trying to see it in the telescope right now, you'd basically see a dot. You wouldn't be able to pick out too much feature. I'm going to get them moving again, and this time I'm going to stop them when Mars gets back to that starting point. So it's right about here. And you'll notice Mars has made it all the way around, but Earth isn't quite back to that point yet. That's because Mars doesn't take a full 2 years to get around its orbit. It's more like 1.9, 1.88. It's actually 687 days. That turns out to be about a month and a half shy of 2 years. So Earth now has to catch up to Mars in order to pass it again. So we're going to go ahead and do that. I'm going to get them moving and try to stop them just when we're passing, right about there. So now we're on the inside track, which means that we've got the sun on one side of us, and we've got Mars on the opposite side of us. They're on opposite sides of the sky. So we refer to this as Mars opposition. So we're closest to Mars at this point, but we do refer to it as opposition. And this actually now is right now. This is where we are, October of 2020. So I'm going to get them moving again. And I'm going to stop them this time when Earth gets back to the spot where we were now. So it's about there. This would make it October of 2021. And now, once again, Mars is on the far side of its orbit. So it looks to us like it's passing behind the sun. Mars and the sun would be at about the same spot in the sky. So we refer to this as Mars conjunction. Okay, I'm going to get them moving again. And this time I'm going to stop them when Mars gets back to that spot. And once again, it's going to be a case where Mars gets there about a month and a half ahead of Earth. So now Earth has to catch up again. And we pass right about there. So you see we had an opposition here in 2018, one about here in 2020. We get another opposition here in 2022. You can see how these oppositions are migrating around the orbit. So let's take a look at a bunch of these oppositions. These are from 2012 to 2027. And you can see we had an opposition in 2012, one in 2014, one in 2016, 2018, 2020. They're about every 2 years. But let's take a look at exactly how long this is. It's going from July 2018 to October 2020. So it's July, August, September, October. So 2 years and 3 months. Okay, so it takes 2 years and 3 months. So then the next opposition will be from October of 2020 to December of 2022. November and December, it's 2 years and 2 months. And then the next one after that is December of 2022. So December of 2024 would be 2 years, and then January of 2025, so 2 years and 1 month. So what's going on here? Why does it keep changing on us? Well, if you've been looking carefully at Mars' orbit, you might notice that it seems like it's a little lopsided. Like it's a little farther out from the sun when you're down this side and closer to the sun when you're up this side. In fact, Earth's orbit is very, very circular. And so when it's in closer to the sun, it's also in closer to Earth's orbit. This close point is called perihelion, which is half Latin and half Greek for close to the sun. They like to use lots of different languages to make them sound sophisticated. And then we've got the far point, which is opposite where the perihelion is. This is called aphelion, which means away from the sun. So, and you can think of A as being for away. So as Mars moves from perihelion, this close point, and it climbs out away from the sun to this aphelion point, it's moving out against gravity. What do you suppose that's doing to its speed? It's pretty much like you throw a ball up in the air, it slows down, arcs over, and comes back and speeds up as it's coming back down. Well, as it's going from perihelion to aphelion, Mars is slowing down. And then as it goes from aphelion back down to perihelion, it's speeding back up. At perihelion, Mars is moving 59,000 miles an hour. At aphelion, it's moving 49,000 miles an hour. So there's a 10,000 mile an hour difference between Mars at perihelion and Mars at aphelion. So now let's go back to this 2018 opposition. When Mars has gone all the way around its orbit and gets back to this point in 2020, again, Earth is about a month and a half away from getting to that point, so it has to catch up. It's trying to catch up to a Mars that's moving 68,000 miles an hour, and it takes longer to catch up. It takes 2 years and 3 months to get there. Whereas if we look at these oppositions that are close to aphelion, when we're in opposition in 2025 in January, by the time Mars gets all the way around to the same point in 2027 or late 2026, we're once again a month and a half behind. We're trying to catch up, but it's a much slower Mars that we're catching up to, and we get there quicker. So you can see this variation in Mars speed by looking at these gaps. You get a small gap, and then it gets bigger, and then bigger, and then bigger. These gaps between the oppositions, and then they start getting smaller and smaller again. So very small gaps in oppositions close to aphelion, wide gaps between oppositions close to perihelion, which means that oppositions that are close to perihelion, like the one in 2018 and the one in 2020, are actually scarce because Mars is kind of hard to catch when it's close to perihelion, whereas the oppositions that are over by aphelion tend to be more frequent, which is a damn shame because when Mars is at perihelion, that's when it's actually closer to us. When it's at aphelion, it's farther. How much, you can see, this chart's got a lot of information on it. So this is a good reason to get the slides. You can see in 2018, it was 0.3862, about 39% of an astronomical unit. An astronomical unit being the distance between the sun and the earth. So 39% of this distance here. In the current opposition, Mars is about 0.4181, about 42% of this distance. So really only about a 3% difference between these two oppositions. So they're both very, very good, very close oppositions and great opportunities to see Mars. When we get out to 2027 and we pass in February 2027, the distance between Earth and Mars is 0.6780. or about 68% of an astronomical unit, almost twice as far, which means that Mars will be only about half the size that it is right now as we're passing it in opposition. So this is not just a good time to see Mars, it's an especially good time to see Mars, and a bit rare as opportunities to see Mars go. And in fact, this particular opposition is especially rare. I'll talk about why. But these are great opportunities to be able to see Mars at a time when it's not just a tiny dot, but a disk that's large enough for us to be able to pick out features on the surface of Mars. So it's kind of nice to know what those features are. So let's take a look at what some of the features are on the surface of Mars, kind of get some key reference points and learn how to sort of navigate your way around on Mars. And in order to do that, I'm going to use this picture, which is actually some Hubble shots that were taken of Mars quite a few years ago, but they're very, very good at showing you the different landmarks on Mars. And the 4 shots are basically 4 sides or 4 quadrants of Mars. So the Acidalia side, if I take this and I turn it a quarter turn to the east or to the right, I get this view here. So you can see all this dark stuff that you see going down the middle of this Acidalia side is going down the eastern limb of Mars now on the side that I'm calling Tharsis. And then I rotated another quarter turn and I get this Elysium side. I turn it another quarter turn and I get the Syrtis Major side, just so you get the idea of what these pictures are. So let's take a detailed look at these. I'm going to start with Acidalia, and this is actually a very, very good starting spot as a sort of a reference for a number of reasons. First of all, you've got a lot of very distinctive features on this face. You've got this dark peninsula that's sticking down from the north. This is called, this is called Acidalia Planitia. Planitia is just a fancy word when you're talking about other planets for low plane. So this dark peninsula is kind of sticking down, and it sits opposite of this spiky region that's sticking up from the south. The spiky region is called Margaritaville, not to be confused with Margaritaville. I don't think that Jimmy Buffett has ever been to Mars. I'm not certain about that, but I don't believe he's been there. So you've got Acidalia Planitia, this dark peninsula sticking down, this spiky region sticking up. Over to the, pointing towards the east, you've got this little skinny wedge that's kind of pointing east and has this big bite mark taken out of it. This is actually called Meridiani because the prime meridian for Mars, the 0 degree latitude line, cuts right down through that piece of the sort of this fat back part of the wedge. So that's another reason that this is a nice reference point. This is the 0 degree line for Mars. It's the prime meridian. And then if those aren't enough, for any of you who saw the movie The Martian, Acidalia Planitia is, in fact, right smack in the middle of Acidalia Planitia is where Mark Watney got marooned. And in fact, he goes down to the southern tip of this dark peninsula here to get the Pathfinder lander and take that back up to the Ares 3. And then he manages to make a trek all the way down here and across over and into that bite mark in the skinny wedge in order to get to Ares 4 where he launches off of Mars. So the whole movie takes place on this face. You got lots of very distinctive features here. Then we get to the Tharsis face. And what are the very distinctive features on the Tharsis face? Nothing. At least not what you can see through a telescope, although a lot of photographs that we'll see, you'll see there actually are some very distinct features, but they're subtle and they're nowhere near as prominent. They don't come around smack you in the face like these ones do. This is the side that has the volcano Olympus Mons, the largest volcano in the solar system. You see this faint little ring is actually clouds around Olympus Mons. There's also a range of volcanoes, 3 volcanoes called the Tharsis Montes that are sitting right about here. I promise I'll get you a better picture of this so you can really see them. But really, when you're looking in the telescope, the thing that tells you that you're here is lots of dark stuff over on the eastern limb, which is all this stuff, Acidalia and Margaritifer, all this dark region. When it's sitting over on the eastern limb, that kind of tells you that you're over the top of the volcanoes. There's a few other clues that when we get to other examples, I'll show you. Then we rotate this again another quarter turn, and now we're over the Elysium view. This is named for the Elysium plane, which is really the center of this face of Mars. And what gives you the hint that you're on this plane, you'll notice that there's a dark region on the south side that with a border that kind of angles up from east to west. It goes from very far south and angles up. So it's kind of a diagonal slash across Mars. When you see that diagonal slash, that's your hint that you're looking at Elysium. There's a couple other things I'm going to show you. First of all, you remember Olympus Mons. When we rotate it over to the right, all of a sudden Olympus Mons is now on the eastern limb where the sun is setting, and you're getting a whole bunch of clouds grouping around Olympus Mons. So now you can see Olympus Mons much more clearly here. There's another fairly large volcano right in the middle of the Elysium Planitia. Yeah, I told you about Planitias. This volcano here sitting in the middle of Elysium is similar to Olympus Mons. And since it's sitting in the middle of Elysium, you'll never guess the name. It's Elysium Mons. Okay, and then we've got a little dark spot here and then a slash. The dark spot's sort of like a guppy right there. You see that? And then a little slash sitting there like that. And you probably only hear me call it this, but I call them the guppy and the slash. The guppy and the slash are actually kind of nice to be aware of because they mark off a very significant area on Mars. It's called the Arcadia Planitia. There are no arcades there, but when people go to Mars, that's where we're probably going to go to play. This is a prime landing site for setting up a Martian base. And we'll look at that a little bit more closely in a second. Sorry, I keep hitting the button. So then we've got the Elysium, and this diagonal slash kind of leads up to the next phase. So when we rotate another quarter turn, we've got the diagonal slash leading up to Syrtis Major, this dark peninsula that's sticking up from the south. This is probably the single most distinctive feature you will see on Mars. If you're lucky, looking at Mars, even if you're looking at it through a 4-inch telescope, you will be able to recognize Syrtis Major on the face. It's a huge arrowhead saying, here you are, this is where you're looking, Syrtis Major. Just behind Syrtis Major, you see there's like a round cloud bank behind it. These clouds are accumulating in a basin called the Hellas Basin. The Hellas Basin, also known as the Hellas Crater, is the largest visible crater in the solar system. So Mars has a lot of the largest volcano and the largest visible crater, and that's not, there's more I won't get into. Now also, over on the western limb here, you see that skinny wedge is starting to come around, the one that we were looking at on the Acidalia side. You can see the skinny wedge here with the bite taken out of it right there. So let's take a closer look. I want to give you a better look at this crater here. So we'll go to the next slide now. And I've turned Mars upside down, so south is up. And you can see Syrtis Major now, which is a peninsula coming up from the south, is now pointing down. And Hellas Crater, you can now see very nicely and clearly behind Syrtis Major. This is one of those features that when you're looking by eyeball in the eyepiece in the telescope, looking at Mars, if you're lucky, you get a clear enough night, you will just be able to pick this off, which is kind of neat. And then this gives you a very nice clear picture of that skinny wedge that I've been talking about. And you can see here that the bite that's taken out of it is actually a crater. That crater is called the Schiaparelli crater. So you get a better view of it here. Here's the skinny wedge. There's the bite mark, the Schiaparelli crater. And you can see Acidalia here, the Acidalia Planitia. You can see the spiky region across from Acidalia. So Margaritifer is right there. You can actually see Syrtis Major with a big cloud bank over it. Usually things that are on the horizons, either the dawning horizon or the sunset horizon, usually seem to have a lot of clouds. The crater, Schiaparelli, was actually named for a guy by the name of Giovanni Schiaparelli. He was an astronomer who did a lot of observations on Mars in the late 1800s, and he made lots of sketches. And one of the things that he observed, of course, the telescopes weren't as good back in the late 1800s as they are now. So what he was observing was what he thought were channels or gullies that were going across, and they seemed to be leading between these areas of dark albedo. So he marked it down, he drew what he saw, he reported them as channels or gullies. It turns out the word for channel or gully in Italian is canali, which led to a mistranslation into English as canals, which led to a lot of popular speculation that there was intelligent life on Mars that was building these canals, which led to Jules Verne's writing War of the Worlds, which led to Orson Welles doing a radio show, which led to mass hysteria and panic. And I don't think Giovanni really meant to set all that in motion. So I think that they named the Schiaparelli crater after him by way of consolation, sort of saying, hey, dude, it's okay, well, it's not your fault. I promised you a better view of the volcanoes, and here they are. This is Olympus Mons. These three, you can see them now very clearly, the three volcanoes in a row. These are called the Tharsis Montes, which is why I call this the Tharsis view. And then Olympus Mons, of course, like I said, is the largest volcano in the solar system. It's 3 times taller than Mount Everest. It covers an area about the size of the country of France or the state of Nevada, depending on your preferences. So it's big, it's big. And then to the northwest of Olympus Mons, you can see this, it's sort of edge on, but you see that guppy again, the guppy and the slash. This is the Arcadia region that I was telling you about. And the reason this is a prime target is because satellites that we've got over Mars using radar have identified huge areas of water permafrost that's not too deep. It's fairly shallow underneath the surface, and so may be accessible. These are big. It's like 130 feet deep, and it covers an area the size of Texas and Florida. So it's a fairly large reserve of potentially accessible water, which will be very important for sustaining an ongoing Martian base. So this is a very important area that may take on a lot of significance in the future. Okay, so sort of taking everything into view in once, you can see this is the Arcadia Planitia that I was just talking about. We've got Olympus Mons here. We've got the Tharsis volcanoes here. We've got Acidalia Planitia up here, the spiky region, the Margaritifer area. Terra Meridiani is the skinny wedge that I was telling you about, the Schiaparelli crater, Syrtis Major and Hellas Planitia, and then Elysium Planitia over here. Now you can see there's lots more detail known about Mars. There are lots more features, but these are the ones that you can really reference off of when you're looking through the telescope, or for that matter, when you're looking at photographs that have been taken through telescopes. So now that you've got all this down, I think it's time for your Martian geography quiz. Let's see how we're doing here. So quiz number 1, where are we? Now here, north is up, and you see this little arrow with the P here, or line with the P. The P is for preceding. That means the side into which the planet is rotating. And you can kind of see that here. These are really good shots that were taken just back in July of 2020 by Damian Peach. And Damian always seems to get the best shots. And he took these 3 in succession. This one is taken close to 4 o'clock. This was taken close to 5 o'clock. This one was taken close to 6 o'clock. And you can see some features rotating into view. Anyone want to hazard a guess at what some of these features are that we're looking at? Did go by kind of fast, didn't it? Okay, so this is that dark peninsula sticking up from the south. Remember, this north is up. So you can certainly see the south polar cap. And then you can see this dark peninsula, Syrtis Major, sticking up. And then behind Syrtis Major, anybody remember the name of it? You have to unmute. Oh, they're all bashing. Hellas crater. Okay, you're doing great. So we're going to go to the next question. Now, this one is kind of interesting because this one shows in this oval, what this is marking is a region where this is the 2018 opposition that we had. And you can see quite a bit of detail here, especially in this dark oval in April. By the time we got to June, it's completely obliterated. This is a dust storm that has obliterated all this detail and kind of fuzzed this detail out. But can anybody tell me what this piece here is that we're seeing?
Edge, isn't it?
That's
The
right
wedge?
here. Yes, that's the
Schiaparelli
skinny
crater.
wedge. So that makes that very good. That makes that Schiaparelli crater, which then would mean that this down here would be, this thing sticking down from the north would be Acidalia. And then the spiky region sticking up from the south is not Margaritaville, it's Margarita Fir. Okay, so you can very clearly see Margaritaville. You can very clearly see Acidalia here, and they've just been wiped out by this dust storm. This is in early June. This dust storm ended up lasting from June to September, and it only got worse. So this very close pass that we had to Mars in 2018, on which many, many people had high hopes pinned, was really, really kind of brutalized by that dust storm. We'll see more of that in a minute. Okay, so where are we now? And your hint is, you can't really, I don't really see any distinctive features here. So we must be over the volcanoes. And you can actually see the volcanoes here. My wife was able to pick them out. The Tharsis Montes are here, here, and here, the Tharsis volcanoes, and Olympus Mons right here. So you can see the volcanoes show up. And interestingly enough, when you're looking at Mars from the south, you got the south polar cap up here. When you're looking at Mars from the south, there is an interesting feature that you can see. If you look here, you see this kind of outline that I'm showing here, and then a dark area here. So it kind of looks like an eye. It even has wrinkles over here. This is known as the eye of Mars. We'll see another example of that in a second. Okay, so this is the Tharsis face here, the Tharsis Mountains, Olympus Mons, and the Eye of Mars. Okay, where are we? Well, actually, we're everywhere. This is a set of 8 images that were shot by Lee Keith using the A scope on Milwaukee Astronomy Club's grounds. That's the 12.5-inch Newtonian reflector that the club likes to refer to as the planet killer. And he did a spectacular job here. He took shots throughout September, right into early October. This last shot is the night before our closest approach to Mars. So does anybody see anything that is immediately recognizable in the September 1st image?
Hellas?
Yes, you can see Hellas right there. And this is actually the skinny wedge here. So you got Schiaparelli.
Schiaparelli, yeah.
Yep. Okay. And then in 9.3, you can actually still see those guys. And what are we looking at here? This big prominent dark peninsula sticking up from the south.
Syrtis Major.
Syrtis, yes, Syrtis Major and Hellas, the skinny wedge, and Schiaparelli crater, of course, the south polar cap. Now you notice how the skinny wedge is sort of rotated a little bit to the west. And when you go to the next night, September 4th, Syrtis Major is kind of rotated a little bit to the west. I believe that Lee took these shots all about the same time of night here. But what's happening is Mars's a solar day for Mars is actually 24 hours and 40 minutes. Mars rotates just a little bit slower than Earth. So if you're taking this picture at exactly the same time, one night after the other, Mars isn't quite making it around as far east as it was the previous night. And so it'll look like it's progressing west. So you can see Syrtis Major right on the edge and then inching in and then moving to the center. You can see it kind of rotating into view as if Mars is moving to the west. And really that's just the slower rotation, and we're catching it before it gets back to where it was. So now we go from 9/4 to 9/14. So now instead of 1 or 2 nights, it's 10 nights later. And he's taken these shots again at the same time. And so the planet has seemed like it's rotated to the west. So anybody remember what is west of Syrtis Major? Or maybe you remember what that diagonal slash was?
Elysium.
The spiky-
Elysium. And you guys are good. Yeah, we're looking at Elysium here. It's really given away by that diagonal slash. That really kind of marks it very clearly for you. So you're looking at Elysium here. And then from 9/14 to 9/23, now it's another 9 days. It's really rotated pretty far west. And so now what are we looking at? Anybody want to take a guess?
That is Acedia or
Beg pardon?
that is Acedia or
No, not quite. We're not quite there yet. You see
The
this
eye of
picture here?
Mars.
Yeah, you see the eye of Mars? Lee caught this beautifully. That is a really gorgeous shot of the eye of Mars. So he really did a nice job with this, which means that we're looking at the Tharsis volcanoes and Olympus Mons. They're very, very hard to see. I'm not sure how big this is on your screen, but I can show you right there, the Tharsis volcanoes in that oval there. I'll sort of blink that. And then Olympus Mons down here. You actually can, you actually can see, I gotta get back here. You can see the volcanoes on this one, if I can stay on the slide. Okay, and then 6 days later, Mars seems to have rotated west again, and now you're looking at that spiky region, and like you were saying, Acidalia, really the very southern tip of that dark peninsula. And then spiky region here, and maybe a little bit of the skinny wedge kind of rotating in. And then a couple nights later, 10/1, you're now seeing the spiky region, Acidalia, skinny wedge. And then 10/5, this is the night before we are very, very close to the approach. So we're very, very close. And he gets a very beautiful picture of Schiaparelli and Meridiani. You can kind of see Syrtis Major over there. You can see Hellas down here. You can actually see Margarita here, a little bit of Acidalia. I mean, there's just a ton of detail on this shot. Notice the difference between the shot in September 1st, when we weren't quite at opposition, and the shot 10/5 when we were very, almost like maybe 6 days away from opposition. So,
Okay.
and see how much the size of it changed.
Okay, yeah.
So this is a really nice sequence of shots that we got. Nice work on his part. Okay, so if you're out looking through your telescope and trying to see stuff on Mars, and you remember that Randy showed you a bunch of stuff, but you don't remember what any of it was anymore, you can just run right inside and look at the Sky and Telescope site. And you see this link for tools here. If you go up to that link and click on that, it takes you to their tools page. And then you scroll down and it takes you to something called the Mars Profiler. And you click on that, it takes you to the Mars Profiler page. And I have several times made the mistake of clicking on this picture that they've got. That's not really it. It's the link right there. And when you click on that link, it brings the actual tool up. And this tool shows you exactly the side of Mars that you're looking at and exactly the point that you're looking straight at for that moment. You can also input any date and any time and see what you were looking at last night or what you can expect to see tomorrow night or any particular time. You can see, you know, when I get my new telescope, what's going to be up for Christmas. By the way, Mars, even though we're passing Mars right now, that doesn't mean that you've completely missed it. It will be about, I mean, it's very big right now, like 22, 23 arc seconds. It will be about 3/4 that size, even by Thanksgiving. And if you don't get your telescope until Christmas, you'll still be able to see it at about half the size it is now. So it's going to be big for a while, and you still got the opportunity to be able to see Mars. So how much detail will you be able to see in that new telescope just by eye? Well, it's going to depend on a couple of things. Of course, it depends on how close we are to Mars. And you can see in this 2018 opposition, you can see how much of a change there was from February through to July. When they were closest approach, Mars was about 24 arc seconds across. This opposition, it's around 22, 23 arc seconds across, so pretty close to the same size. And that, of course, is a big chunk of it. But it also depends on two more things. First of all, it depends on the resolving power of the scope that you're using. And you can calculate that resolving power very simply. The resolving power is the tiniest little dot that your scope can resolve before it becomes just a blur. So if you have, for example, a 4-inch scope, you take 120, divide that by the diameter of your scope, which in the case of a 4-inch scope would be 100 millimeters. You divide 120 by 100 millimeters and you get 1.2 arc seconds. So that would mean that the scope is able to see 1.2 arc seconds, which is what, about a 20th? So anything about a 20th the diameter of this. So maybe some of those big things like Syrtis Major, you should be able to resolve in even a 4-inch scope. And then you can look at, for a 6-inch scope, you get 0.8 second arc second resolution. 10-inch scope, you get about a half arc second resolution. There's a half arc second resolution on a 24 or even 20 arc second diameter. You should be able to see a lot, except for that there is one other factor that kind of works its way into this. And that's got to do with the fact that you can breathe while you're looking through your telescope. The fact that we have a breathable atmosphere does come with a cost. It messes up your image in two ways. One is called transparency, and the other is called seeing. Transparency is basically the background sky glow, and the brighter that background sky glow is, the harder it is for you to see faint things. The thing is, when we were looking at Mars, you're not looking at a faint thing. Mars is extremely bright, so transparency isn't really a factor. But this other thing called seeing is. Seeing refers to the turbulence in the atmosphere causing shimmering and shaking of the image. It's a lot like looking over the top of a hot asphalt surface and you see the air kind of boiling over it, and it kind of causes everything to shimmer and fuzzes things out. That can also limit your resolution. On a typical night, it will limit you to 2 or 3 arc seconds. If you get a really good, clear, calm night with very good seeing, you might get down to 1 arc second. But that's going to be another limiting factor. So to give you an idea of what you'd actually be able to see in a scope, I'm using a shot that was taken by a friend of mine, Ron Lundgren, who took this through his 8-inch Celestron scope. And it might be because I'm looking through an 8-inch Newtonian scope that this looks pretty much like what the view is through a scope, but I think that this is pretty representative of what Mars looks like visually when you're just looking at it through the scope. You can make out the southern polar cap. You can see Syrtis Major quite clearly on this one. You can see what might be the Schiaparelli crater over here. On a really good night, I was just able to make out Hellas. So this gives you a sort of an idea. But of course, you need good weather. You need no clouds. You need good seeing. And actually, you need not just good weather on this planet, you need good weather on both planets, Mars and Earth. And so let me show you what happened in 2018. This ended up being a global dust storm, so that huge conspicuous features like Hellas or Syrtis Major just disappeared. It was next to impossible to get even a decent shot. And even on the surface of Mars, things weren't so great. This is the Curiosity rover taking pictures during that sandstorm. It was trying to take pictures of the rim of Gale Crater, and just 10 days in, you couldn't see your hand in front of your face. It started clearing up about 3 months later in September, but this is June. And then this is, you can see the sols counting by here. This is 10 days later. You can barely see your hand in front of your face. So the weather on Mars can be kind of brutal. And this was tough even for things like the rovers because they're running on solar power. And this sandstorm was so badly obliterated things that they couldn't even get enough sun to get solar power. And that's the real issue here when you have these sandstorms. So take a look at conditions on Mars to understand that. The atmosphere is almost entirely carbon dioxide. There's a little bit of nitrogen, a little bit of argon, but an atmosphere of carbon dioxide is not very useful. Even if you're breathing 4% carbon dioxide, that's toxic for you. So 96% carbon dioxide is not good news. But it really doesn't matter because the pressure on the surface of Mars is around 6 or 7 millibars, where Earth's average pressure is about 1,000 millibars, 1013 on average. To put it in other terms, pressure on Earth is 14.7 pounds per square inch. On Mars, it's less than 0.1 psi. So if I were standing around on Mars, I would want to be in a pressure suit because I choose life. The temperature on Mars, if the pressure and the atmosphere weren't bad enough, the temperature on Mars is also a bit chilly at minus 80 degrees Fahrenheit on average. Around the poles, it can be minus 200 degrees Fahrenheit. From time to time, it can get to be around 70 degrees Fahrenheit at the equator, but I'm not taking off my pressure suit. And the winds on Mars tend to run around 10 to 20 miles an hour. In a dust storm, it can get up to 70 miles an hour. Now, once again, if you saw the movie The Martian, and you saw the wind blowing the dish antennas all over the place and almost knocking over their spaceship and throwing people on their butts and howling around the thing, it's actually not what would happen. Because you remember I said the pressure is only about less than 1% of what the pressure is on Earth, which means the atmosphere on Mars is less than 1% of the density of the atmosphere on Earth. So even though those winds are whipping at 70 miles an hour, if you could stand there in shirt sleeves, you might be able to just feel a gentle breeze. It's equivalent to a breeze on Earth of about 6 or 7 miles an hour. Now, if you're in your pressure suit, you might actually be able to feel the wind once in a while if you get hit by a dust devil. Because the winds inside a dust devil can be up to 200 miles an hour. That's about the equivalent of a breeze of about 20 miles an hour on Earth. So you might just feel them. The rovers going around on Mars love the dust devils. They love them because when the dust devils go over them, it blows the dust off their solar panels and they see a sudden boost in power. And those rovers do see a lot of dust devils. These are all images that were captured just by the Spirit rover. And you can see it saw quite a few going by. If you watch this one in the middle, you watch very carefully on the ground, you might notice that it's actually leaving a trail. When this picture clears, you'll really see it. See that? It goes by and it leaves a trail. You can see these trails. The surveillance satellites going overhead can actually see these trails. They like to call them the devil's scratch marks or something like that. But anyways, you do see lots of collections of dust devil trails going around the surface of Mars, some places more than others. And they do, sometimes these satellites will see dust devils themselves. This is one, and that's not a trail, that's the shadow of the dust devil. And this is about a half a mile across this image. So the dust devil, turns out, is more than a half a mile high. Some of these dust devils have been measured as high as 5 miles. This is a shot that was taken by the Mars Reconnaissance Orbiter, which is one of 14 satellites that are still orbiting Mars. I think 6 of which are active. So we've got 8 dead satellites that are orbiting. But those are not the only satellites. Those are the man-made satellites. There are 2 other satellites orbiting Mars. Mars does have moons, and I'll put that in air quotes, but it does have moons. You've got Phobos, and the other one is Deimos. Deimos is about 8 miles across, and Phobos is 14 miles across. For scale, Our moon is 2,000 miles across. So these are more like moon chips. But theoretically, you can see them from Earth. In fact, in theory, you would be able to see them in a 4-inch telescope because Deimos is a magnitude 11.8 and Phobos is a magnitude 10.7, which are well within the capability of a 4-inch telescope if you got a nice dark sky. Except for that, there's one other thing in your field of view. It's this thing here, Mars, which is a magnitude minus 2.5, and the glare from Mars is what makes it really hard to see these. I'm told, though, that if you get a nice dark sky and a 10-inch telescope, you actually can pick out these two moons of Mars. And Phobos is really hauling the mail. I'll talk about that. You can also see these moons from the surface of Mars. These are images taken by Curiosity of Phobos eclipsing Deimos. You can see Deimos come popping out here in a second as it comes out from behind Phobos, right there. Hello. And to give you some idea how big they appear in the sky from Mars, this is comparing to the view of our moon from Earth. Now, if you're wondering why a 2,000 mile across thing looks even close to the size of these 8 and 14 mile things, it's because our moon is much farther away. It's 250,000 miles away, whereas Deimos is only 25,000 miles off the surface of the moon, or off the surface of Mars, which is 10 times closer than our moon. And Phobos is only 9,000 miles above the surface of Mars, which means that it is orbiting really fast. It's orbiting faster than Mars is rotating. So if you want to go there and see those yourself, there are plans to get us out to Mars in the not too distant future. Someone asked Elon Musk, who's the owner and CEO of, or the founder and CEO of SpaceX, whether this Mars colony that he was trying to set up would be an escape hatch for the rich in the event of a cataclysmic event or extinction level event like an asteroid hitting Earth or a huge volcano exploding. And he said, no, really the ad for going to Mars would be like Shackleton's ads for going to the Antarctic. Shackleton, in 1914, Shackleton said, men wanted for hazardous journey, low wages, bitter cold, long hours of complete darkness, safe return doubtful, honor and recognition in event of success. And that's what he's kind of comparing the trip to Mars to. He says it's going to be hard. There's a good chance of death. Going in a little can through deep space, you might land successfully. Once you land successfully, there's a whole passage here where he talks about how much hard work there is and very little time for leisure. And even so, there's a good chance of death. We think it can come back, but we're not sure. Okay, so everybody ready? Here we go. This would be your spaceship. This is the spaceship that, in fact, SpaceX is now building. And this is a company that is absolutely determined to go to Mars. And they've been having tremendous success with all the innovations that they've been doing, like the first orbital rockets to land and be reused. So I would not bet against them. This front part of the rocket is the actual spacecraft that would go either to the moon or to Mars, or just to carry cargo up to, or people up to orbit. And this booster here is what they call the Super Heavy booster. Both of these pieces are designed to be completely reusable, as in the way an airplane is completely reusable. They will fly them, land them, refuel them, and fly them again. The plan is for these things to be able to make as many as 3 flights a day. By comparison, the space shuttle was able to make 3 flights a year. So they're redefining the idea of reusable. And they're going to be testing, they're going to be doing, I think, a 10-mile high flight test of the Starship, that's the spacecraft in the front. By the end of this month, they're looking at doing that. Or certainly by the end of the year. And they plan on putting this thing into orbit by the end of next year. But you can also just take a look at the size of this thing compared to the Saturn V rocket. It actually dwarfs the Saturn V rocket, the largest rocket and the most powerful rocket that we've ever launched. But the Saturn V rocket was 7.5 million pounds. This super heavy booster will be 16 million pounds of thrust, twice what the Saturn V booster was. So that's your ride. And you won't get to Mars by just aiming at Mars and then going there. There's three things you have to do in order to be able to get to Mars. First of all, you have to escape Earth's gravity, and you have to do so with enough velocity that you put yourself into an elliptical orbit where the perihelion is at Earth's orbit and the aphelion, the high point, either just touches Mars's orbit or goes a little bit beyond it. So you get into this elliptical orbit to reach Mars, to lift yourself from Earth's orbit to Mars orbit. And then the third thing is you have to time it so you get there when Mars does. So there's an example here of the InSight probe that was launched towards Mars. And you notice how it kind of comes in front of Mars, because as it reaches aphelion, it's slowing down. So Mars actually catches it from behind. And that's what you would be doing. You'd be arriving at Mars's orbit ahead of Mars, and Mars is actually catching up to you, will catch you in its gravity. And then depending on how you're trying to, what you're trying to do, in some cases, when they're putting a spacecraft out to Mars, they're going to try to put it in orbit. In this case, you're trying to land. So you'll do a direct descent and use the atmosphere to slow you down. The one whole side of the Starship is a heat shield. And so this thing does a belly flop into the atmosphere, heats up on one side, and then in order to land, actually lands under rocket power. So a lot of these Falcon 9 rockets that you've been seeing, these orbital class rockets that have been putting stuff into orbit and then coming back and landing either at Kennedy Space Center or on a barge in the ocean, this has all been just preparation for how they plan on getting us to Mars. Now, the first ships that get to Mars will be cargo ships. There'll be supplies for the humans that first land there. And there'll also be a little bit of robotics, some to start manufacturing methane fuel so that we know that we have a ride home, and other robotics that are going to be there to build shelters. They're going to 3D print shelters basically made out of crushed Martian rock and polymer material that creates a Martian concrete. And then they will, as I said, 3D print a shelter. And then inside that shelter, they will move inflatable habitats that would give you a pressurized living space. And those will be put up inside the shelter. I think this is cool because they show a lot of things in here. A couple of the things that are of interest, though, that I wanted to point out is they've got like a little garage here hooking up to an airlock. And you notice they've got a couple of spacesuits that seem to be parked outside, but hooked up to an airlock. That would actually be the plan. And the reason for that is because the Martian dust gets on everything. It sticks to everything. It's electrostatic. It gets everywhere. It messes up mechanics. But on top of that, it's toxic. It has perchlorate salts in it, which are toxic to humans. And so you got to do everything you can to prevent the Martian dust from getting inside. So even the spacesuits park outside. But why do you suppose these guys want to have this big concrete shelter over the top of the habitats? Well, it turns out that Mars is a really bad environment for a lot of reasons, not just the dust and the dust storms and the cold and the lack of pressure, but also radiation. The surface of Mars has no protection from solar winds or cosmic radiation, and so they need this. Earth sort of benefits from the fact that it has a magnetic field, which kind of diverts the solar wind and diverts cosmic rays and prevents them from hitting the planet. For that matter, this magnetic field also protects the Earth's atmosphere from being blown off by solar winds. But Mars didn't have that benefit. Mars does not have a large magnetic field like that. I think it's got some weak local ones that they might want to try to make use of, but there's no large magnetic field like that. So you need a radiation bunker in which to live. But once these things are built and established robotically before people even arrive, then we're in position for people to arrive. So just recently, I think there was an update to their plan. They're now looking at getting the cargo ships with the robotics out to Mars around 2025, which sounds a little bit more sane, and sending people to Mars in the 2027 opposition. So people arrive and they start expanding the facilities. They start storing fuel so that they can get ready for the trip home. They set up agriculture so that they have a self-sustaining colony. And eventually, Elon Musk at least, SpaceX plans are to try to build that base into a village and then into a full thriving city. They want to get a Mars colony, a permanent residence up there. Elon Musk has some interesting ideas, and I've seen some interesting thoughts in terms of the economy of this and what it would take to actually make this happen. One of the things that he believes that he can do is reduce the cost of a ticket, well, actually moving to Mars. So that would be the transport over to Mars and buying yourself a house and property on Mars for $200,000. And he thinks if he can do that, that there's enough incentive for people to be able to get there, to be able to get good jobs for good wages and be in a pioneering new effort on a new frontier. He thinks there'd be enough people initially to get this thing started. But then economically, how it would support itself is also interesting. There's been a lot of talk of things like being able to mine ore and send it back to Earth. And if you have regular ferries going back and forth, that could possibly be economically possible. But the most intriguing idea was one that was written by Robert Zubrin back in the 1980s. What he said was just the technology that is developed by people living on Mars to solve problems of living on Mars would translate back to Earth, and they would be able to finance their colony just based on selling all this new technology. What I think makes that so interesting is that it's already happening. Things like landable boosters, orbital class boosters that SpaceX is building is changing the economics of putting things up into space. And assuming that they're successful with the Starship and the Super Heavy booster, they're going to reduce the cost of going into space dramatically. Not only that, but they're also talking about point-to-point flights, being able to go from, say, Los Angeles to London in 30 minutes using this technology, using a booster that's completely reusable like an airliner, and just flying you to London and then fuel it up and fly it back. So that's my presentation. That's Mars today and some of the plans for Mars in the next few years. If you have any questions, please feel free to speak up.
Fantastic, Randy.
Very good.
Oh,
Oh, thank you.
great,
Nicely done.
great.
So Randy, when did Elon extend out his time?
I'm not
schedule?
sure when he actually made that change, but I only heard about it last week.
Oh, okay, because it was 22 for
Yeah,
cargo.
he was going for 22 to send the cargo ships out and,
Yeah.
and 25 to send people. But last week he started talking more like 25 for cargo and 27 for people. And actually, to be honest, that sounds a little bit more sane to me, because when you
Sure.
look at their plans for getting to they're going to use that same vehicle to get themselves to the moon. And when you look at the plans for going to the moon, I think you're talking 2022 for sending people in a looping orbit around the moon. And it just doesn't seem like they're going to have enough flight time and experience to trust, if they're only just then doing an orbit around the moon, to
Right.
also be sending things out to Mars. So it just sounds, like I said, a little bit more sane. It's still very aggressive to try to be sending cargo ships with that kind of sophisticated robotics to set up all the habitation and the methane manufacture for fuel, to be able to set that all up automatically on Mars ahead of time it sounds a little bit crazy. But another one of these things that I was talking about, the technologies that I was talking about, just recently NASA put up a competition for automatically building these shelter structures using robotics. And the company that won with this design. And they have, you can kind of see in this, I don't know if you can see it, but you see this little arm sitting over here. And basically what it's doing is 3D printing this habitat over here. Well, they're also doing that here on this planet. They call the Martian version Martia, and they call the Earth version Terra. And they're going to actually build homes like this, sort of developing a similar sort of crushed rock and polymer-based concrete and 3D printing the home. So we're seeing these technologies that are being developed for Mars already bouncing back to Earth. But to me, it's just fascinating to see ideas like this of sending these things ahead and having all this standing by the time people arrive. Any other questions?
So Randy, has there been any discussion about the gravitational effects? You know, right now we have 2 data points.
Oh, yeah.
You know, gravity of 1, Earth,
Mhm.
and you know, and microgravity in the space station.
Mhm.
We actually have no clue on what the health hazards will be for gravity at 0.38.
Right.
And
That's a really good question, and it's one of the biggest concerns, is that these guys are going to be on probably what will turn out to be a 6-month trip
right,
to get to Mars. They're actually, Elon Musk is talking about trying to pare that down to a 4-month trip, and if you put more fuel into it, you can maybe do that. But even then, a 6-month trip to Mars, and then spending however long they're going to spend on a 3rd Martian gravity, and then if they make a return trip, another 6-month trip back. By the time they come back to Earth, will they even be able to function
right.
under 1G of gravity? So yeah, that's a relatively significant concern, and could possibly be an argument for getting some experience on moon bases before they start reaching out to Mars and trying to set things up on Mars. You can gain experience on the moon. It's half the gravity of Mars, but still conditions are very, very similar. I mean, Mars does have an atmosphere, but you can pretty much ignore it. You have to worry about the lunar regolith just as you have to worry about Martian regolith. So the moon could be a good training ground. So if they were to try to set up a moon base and maybe even a sustainable moon base over time and use that to build experience before going to Mars, it actually sounds like a more prudent plan. It's just that Elon Musk is in a hurry. So yeah, that's a good question, and I think it remains a concern.
Yeah. Yeah, because the other issue that the public isn't aware of is when our astronauts come back from the International Space Station on a 6-month period, you know, they're removed from the capsules via stretchers.
Yeah.
They cannot walk and are not really functional for at least you know, the best I've ever heard was 5 or 6 days, you know, to a month.
Yeah. So that really begs the question of, okay, so what's the planned regimen for when you get to Mars?
Yeah.
When you arrive? Yeah, it's 1/3 gravity, but it's still gravity. And so how do they plan on acclimating to being in a gravity environment again before they try to do anything functional? And how critical will it be for them to do anything functional after they've first landed? These are all really, really good questions.
Yeah.
And why does that happen? I'm sorry, I didn't understand.
Why does it happen?
Yeah.
Well, even though they exercise, and by the way, I think they've been improving the exercise. I forget how they said they've been doing it, but they've been reducing the bone loss and reducing the muscle atrophy with some improvements that they've made in the exercise regimen. I think it's just been a matter of increasing the force, but I'm not sure I remember. I think that the sort of a combination of muscle coordination and vestibular I mean, when you've been in zero G, your inner ear just no longer is really functioning that much. You don't have the up and down orientation that the vestibular system gives you. So I think that's part of it. To be honest, I don't know in detail. I just know that what Dennis is saying is correct. That when you saw even these guys that were up there for 3 months on the demo run for SpaceX's Dragon capsule, they were only up there for 3 months. They brought them out on stretchers.
Wow.
Yeah.
Yeah,
So-
there's also major cardiovascular effects. After 6 months, the heart becomes perfectly round, and
Wow.
so it's pumping pressure. So what happens is if those guys try to stand up, they get this, hypostatic, or hypotension,
Yeah.
and so they literally just pass out.
Pass out, right?
Wow.
Not to mention glaucoma and a few other things that microgravity causes.
Huh.
Their eyesight changes significantly over 6 months.
I wasn't aware of that.
Yeah, they actually have requests after 4 or 5 months to send up new glasses. If they're
No kidding.
So it deteriorates?
yeah, so there's effects on the optic nerve
Is
due
that
to the
temporary or
microgravity.
permanent?
Usually, it's all associated with perfusion of blood.
Does
That
it have
temporary
anything
or
to do with the
permanent?
changing the shape of the eyeball as well?
No doubt.
Yeah.
Yeah, given.
Yeah, I would think if they're changing glasses, I would think that was probably
Yeah.
a cause as well. Good questions. Any others? All right.
So, so the next opportunity, the opportunity Musk is targeting is 2027
2027 for people
for people. Okay.
for people to go. Yeah, but they'll be sending cargo ships in 2025.
Okay.
Actually probably late 2024 because they catch it in very approximate terms. They launch about 45 degrees before we get to Mars in terms of orbital angle.
Uh-huh.
It's roughly 45 degrees, give or take, depending on where you are in the orbits. So they kind of lead, or they let Mars lead because it's going slower. And even on that elliptical orbit where you're going between Earth and Mars, you're still going faster than Mars for most of that. You slow down as you get to the orbit.
I see.
When Musk talks about going to Mars in 2027, is that a NASA funded thing or is that strictly commercial?
I have no doubt it would be NASA associated, that NASA will connect up with them. NASA's right now sort of, it's handing out money, and whoever comes up with it first wins. So there's been two, for example, for flights to the ISS, there have been two leading competitors, if you want to call them competitors, for getting astronauts to the ISS. It's been SpaceX, and it's been United Launch Association, what do they call it? United Launch Association or something like ULA, which is actually Lockheed and Boeing. And Lockheed and Boeing are military contract kinds of companies. And so they operate on cost plus contracts. So they take their sweet time getting anything done. Whereas SpaceX is, like I said, bound and determined to get us to Mars soon. And so SpaceX beat them by a lot, getting something going.
Yeah, they're getting ready for their second manned flight to the International Space Station, and Boeing is yet to do their demo flight yet.
Right. Yeah, so NASA's, I mean, SpaceX is ready, so NASA's going with SpaceX. And if SpaceX is the first provider that's ready to go to Mars, then NASA will go with SpaceX.
Oh, great job, Randy.
Okay, well, thank you guys.
Very good.
Yeah, very enjoyable.
Oh, good, I'm glad.
A lot.
Fascinating.
Yeah.